Hi, everyone. How are y'all doing? Welcome to our dynamic session on low-effort, high-impact app optimization. My name is Alice, and I'm going to hand it off to my colleague to kick us off.
Thank you, Alice. Hi, I'm Ben. And in today's fast-paced mobile landscape, app performance is paramount. When developing an app, we're in between the users and business stakeholders. Both have relevant interests, and developers should aim to meet those. Users expect a smooth and responsive experience. They have zero tolerance for slow or janky apps. And app performance directly impacts user satisfaction. From a developer's perspective, we strive to build robust and efficient applications. This means continuously monitoring and improving technical performance metrics. Today, we'll show you how to make things more convenient by improving the developer experience. And finally, for business stakeholders, the technical performance of our apps directly correlates with business outcomes and improved key performance indicators, such as user ratings and retention. A performant app can lead to happier users, better engagement, and ultimately, a stronger bottom line. So, how can we achieve significant performance gains without spending countless hours on intricate optimizations? That's exactly what we'll explore today. We'll walk you through an end-to-end workflow leveraging tools and techniques designed to drive high-impact performance improvement with minimal effort. This will be a dynamic session with some live coding and an interactive section. So expect to see things in action, including, well, a few potential bumps along the way. Let's dive into the tools of the trade with some exciting news that make performance analysis and optimization a lot easier. You might already know Jetpack Macrobenchmark. It's your specialized tool for measuring performance of large interactions, like app startup, scrolling through a list, or navigating between screens. Its core purpose is to provide accurate and consistent measurement results. Jetpack Macrobenchmark captures traces, measures specific sections within those traces. It instruments an application and runs the tests multiple times. And by repeating test execution, outliers will be mitigated, and you can start relying on statistically significant data. Jetpack Macrobenchmark provides several metrics that enable surfacing relevant information within those captured traces. The startup timing metric enables measuring time to first frame and time to full display, two incredibly relevant metrics when it comes to user satisfaction. The frame timing metric provides data on how frames are rendered and then it statistically distributes those. Users do care a lot for startup and rendering performance, so should developers. There's also CPU time and memory metrics. They show how resource-hungry an app is. These are particularly useful when taken in a historical context and help you to spot regressions in that area early on. We also have a trace section metric. This allows you to query all the data from a trace and allows you to surface anything from within those traces. Jetpack Macrobenchmark offers a lot more metrics, and you can check those out in the developer guide. But let's take a look at how to use Jetpack Macrobenchmark. After setting up the test conditions, you can define a user journey, and that will be followed throughout the benchmark. And the user journey consists of a list of actions that a user takes when they are navigating through an app. So it begins by starting the app, then they click some buttons, scroll through content, or enter text. And we have an API for that. That is UiAutomator. And it has recently seen a very significant update, which highly improves the developer experience. Anybody here used UiAutomator before? Awesome. So this is for you. Let's take a look. So to start an app, you now just type start app. Easier than a bit easier, OK, but it gets better. We now have an onElement function, which allows you to take the content on screen, and you find anything there. And to do that, you say, look, there's a text string, and you just search for it. And then you click. So that's a single line. Same thing for scrolling. Like a single line, you look for something that's scrollable, and you just scroll. Easy as that. When you have some more complex things, you can also have a more complex query where you have multiple elements in there. So if something's editable and has a content description with a specific text, do something on there. Manipulate it afterwards. Straightforward. You can do that even in multiple layers. So you can have the children or grandchildren of an element that is on screen and do something on there and take an action there. And waiting was a big issue with the previous APIs. So you had to figure out, is there an animation going on? Is the content there? What's going on? But now a default timeout of 10 seconds is there. And you can just override it by saying, timeout is different, so I want to wait 20 seconds because I know it takes longer. But as a default, you don't have to wait anymore. The API does all that for you. You can try today with the UiAutomator dependency 2.4 Alpha 3. That's the latest that we currently have. Go ahead, give it a try. Let us know what's going on. If you have any issues with it, we really want to hear now before the API is fully stable. So in a nutshell, in the tools, you capture the performance data with Jetpack Macrobenchmark. Then you write the intuitive test code using UiAutomator, and then you have to test those on real devices. Once the benchmark is completed, you get to see results. But what does it mean when an app median startup time is 2.8 seconds, or if the 90th percentile of frames is rendered just a bit over the vsync threshold? Well, for that, we have the app performance score. This gives you a guide in assessing your app's performance, and it helps you provide some meaning to this performance data. You can map the benchmark results to actionable recommendations and gain insights on best practices as well as tool adoption that can help you to improve performance. Each assess criteria provides you with an evaluation and how well your app scores and an actionable recommendation. Within that score, it helps you to see whether you should focus an engineering effort in specific areas. And also, it provides you, for each of those sections, a big picture score from 0 to 100, which you can then give to product owners and say, hey, our performance is at a 40. Nobody really wants to have a performance in that level, but they want to go higher. So apps that start faster, drop fewer frames, apply recent tools, receive a higher score. Give it a try, and let us know how well your app does. With App Startup Insights, we're providing another new performance inspection feature. App Startup Insights enhances existing benchmark results, providing you with detailed information on issues that occurred while benchmarking. App Startup Insights alerts you if there's issues with blocking operations, lock contention, installation time, or DEX processing, slow application binding, long just-in-time compilation, resource loading, and a lot more. Feature landed in the trace processor artifact 1.4 in the latest alpha as well. And you can use it today by any benchmark that you currently have. Just add this experimental config, say startup insights config, set what it should use. Let us know how well it works for you. Let us know if there's any things that you want to see improved there as well. So think of those as your performance analysis toolkit. We have Jetpack Macrobenchmark for the detailed metrics, App Startup Insights for targeted recommendations, and the app performance score for a higher level overview with dynamic and static scoring. Next to this performance analysis toolkit, we also want to show you some real performance benefits in this session. We've seen some truly impressive results from partners who have embraced performance optimization techniques. Today, I'm excited to share the story of how the Android team at Reddit significantly improved their Android app's performance. Reddit implemented a combination of different tools and strategies, including adopting Jetpack Compose, using the R8 optimizer, and leveraging baseline profiles. Today, I want to focus specifically on the impact of R8, the Android app optimizer. Reddit had already been using R8 in a mode that only makes use of basic optimizations. The R8 optimizer also provides advanced optimizations, which are default for multiple years now. Many apps don't use those yet. So in our case, after Reddit looked at the app performance score, they saw, we don't do this, and we could get a better score and also see performance improvements after using R8 in full potential. So they said, let's enable R8 to full potential. And the results were impressive. They observed a 40% faster cold startup time, which means a much faster and snappier initial user experience. The ANR rate, so the application not responding errors, improved by 30%, which is a dramatic improvement in app stability. Also, scrolling animations got a lot smoother. Frame rendering improved by 25% across a variety of devices, which improved the overall user experience. And app installation and download time decreased as well, because the app size was reduced by about 14%. By using Android Vitals, Crashlytics, Reddit was able to capture those metrics in the wild on actual devices with real users and compare how much the numbers developed over multiple releases. Along with these technical numbers, Reddit also saw positive movement in their business metrics. So that indicated, well, happier and more engaged users for their app. In the weeks following the rollout, Reddit's average ratings on the Google Play Store improved drastically. The 1-star ratings dropped significantly, while the high end of user ratings, 4 and 5 stars, went up. So after that, we had 92% of Reddit's ratings within 4 and 5 stars, which is huge. Well, that's average, but total, it means this. So in absolute terms, on a Google Play Store, the Reddit app has increased by more than 1 full star in ratings within just 2 months. This really highlights how closely technical and business performance metrics can be related. We asked Drew Hevner, the staff software engineer who worked on enabling the R8 optimizer, about his experience with this. He stated that implementing the changes to enable the R8 optimizer's full potential took less than 2 weeks. So considering the short time necessary to enable substantial performance gains, leading to those sustained user ratings improvements, this is a fantastic return on investment. Reddit's success story really, really highlights the power of app optimization with R8. R8 is a sophisticated optimizer. It analyzes your code and makes intelligent transformations, which can improve a wide range of technical performance metrics. For a long time, R8 was seen as a tool for code obfuscations and shrinking an app size, but the true potential of this tool is code optimization. To illustrate the power of R8 in a practical and actionable way, we're going to apply what we learned to the newly open source Androidify app. You might have seen it today. And the app allows you to take a picture. And, well, there's a booth out there. You can see what it does. In the demo, we use Jetpack Macrobenchmark and the UiAutomator API to quickly write a test for a common user flow within this app. All right. So let's go to the demo. So here I am in Android Studio, and I have a prepared benchmark scaffold. I want to test the basic thing. I want to open the Androidify app. I want to click on the Let's Go button, and then enter a prompt, because I'm not taking a photo here. Then Jetpack Macrobenchmark allows me to capture a lot of metrics. So here I'm interested in frame timing, startup timing, and these 2 custom metrics that use the trace section metric underneath the hood. One of them is JIT compilation, and the other one is the class initialization count. These are 2 metrics that I defined here. And by tracking just-in-time compilation, I can see how effective the app's baseline profile is. Baseline profile that can remove the need for just-in-time compilation of the code that is covered. That improves startup and runtime performance. First things first, I have UiAutomator here, and I start the app. And from there, let's just go ahead like this. This is what the journey would look like. And from there, I want to find the button, Let's Go. And I do on element, text as string. Text as string is different to text, because if you use text, you get a char sequence, and you can't compare char sequences to string, because you always return false. So what we're doing here is we're just saying, let's go. That's the text that I want to compare, and I click on that. So that would be this. No waiting required here, because, again, the API does this for you. Straightforward with the built-in waiting. And from here, because I don't want to text, I don't want to use the photo, I want to use a prompt. Just copying this and changing to prompt. Also clicking here, so that means we're over here now. And now I can do the next thing, which is finding the text, the editable text, the editable view here. What I'm doing here is on element, again, is editable. Because we're doing multiple things here, I do use apply, and first I click, and then I can set a text. Well, blue trousers, green checkered shirt, beard. So that would be that. I don't send this off to the AI, because that would take a while, and I don't want to transform this right now. This would be part of a different benchmark. So I can now switch over, and run this, usually you would run this on a real physical device because otherwise you won't get any proper performance metrics, but for demonstration purposes, this is OK. It provides the results for all this, but instead of waiting, we can just switch back to the slides and see the metrics that we captured here. So I captured this just before the session. There's a lot of data here. So what should you focus on? Let's focus on what really matters. We take a look at the median numbers. So this means in here, the median here, for most of the metrics, and for frame overrun, we're looking at the point where the number turns from negative to positive, so where an actual overrun happens. So that's the 95th percentile. So a lot of the frames are good, but at that point, we see slower frame timing. So the data results show Android app is super fast with 400 milliseconds app startup. We have a JIT count that, well, it's not a lot, and but if there's a lot, it can actually slow down rendering and startup performance. Class initialization is another one that's interesting because reducing the number of initialized classes can also speed up the app's performance. We're also tracking frame overrun and, just for fun, the total frames rendered during that benchmark. The APK size at the time was 18 megabytes, and those numbers come from an app from a version that doesn't use any guided optimization. So neither R8 nor startup, no baseline profiles. So we should be able to very quickly improve those results. So let's go back to a demo. So in Reddit's case, we saw when you configure R8 correctly, you can significantly improve the runtime performance. What we're doing here is, well, we're just enabling R8 in full mode. So is minify enabled, true, and is shrink resources true for resource shrinking, which should shrink the app also dramatically. So is minify enabled means that optimizations are all enabled, R8 is on, resource shrinking is another one that shrinks and removes a lot of things from on the resource side of things. So you don't want those enabled for your debug build or your day-to-day development build because the app gets harder to debug, and also it takes a little while to actually build and run this. But let's see. We're running the app now. With R8 enabled, well, we should expect the optimizer to do improvements, but what just happened? All right, the app crashed. Yeah, it happens a lot. When enabling R8 for the first time. And in here is like, what is that? OK. That's strange. Anyways, so we're seeing a no such element exception. And the rest of this is like, I don't know. There's multiple ways to deal with this, though. And everybody that has enabled R8 for the first time probably saw an issue similar to this. The easiest way to deal with this is to just say, well, we don't want to obfuscate right now for this, and we don't want to optimize. And by adding those, we build the app again, and that should give us more information on what's happening. While we do this, let's talk a bit about R8 and the slides. So the R8 optimizer takes several steps to improve the app's performance. In the shrinking phase, it reduces the app size dramatically, and it also does tree shaking, which removes unused code, and does a couple of other optimizations. It does method inlining, which replaces method calls with the actual code that was in the method, and it does class merging, and some other strategies to make the code more compact. R8 can also obfuscate the app, where classes feel the method names change to shorter and meaningless names. So my activity would become A or something like that, which is what we just saw. So all of these steps are taken to reduce the app size and to improve runtime performance. And, well, build should be finished by now. So yeah, let's go back to the demo. All right, do we have a build? We do not. Oh, there we go. Yeah, the app still crashes, as expected. Wait. Come on. All right, yeah, it crashes. Cool, so now everything is unobfuscated. The crash still happens because R8 is still enabled, but I can see what's happening. So still no such element exception. List is empty. I can click here, like, what's happening? This is the first stuff in our code. Gain access to source. All right, yeah. So I added a class in a library in here that uses reflection to access this constructor, make it accessible, and then has another call here, which is the second one, which is user source, where it actually uses naming reflection, and well, that's not good. And that's most of the problems that you're going to see with R8 will have to do with reflection, either in your code or in somebody else's code. Well, the class probably was just renamed, and that's why it didn't work. The best way to address this is by firstly removing these two. And what I'm doing here is I say I want to keep the class secret sauce, and I don't want to keep everything. I want to narrow this down to the things that I access or that are accessed. So what I know is I have a private constructor, which is this here. So I keep this part. And also, I want to keep this method, which was use the sauce. And I also want to keep this. Now, when building Androidify again, what will happen is this will be kept around. The app will be optimized and should be a lot faster. So while we wait for R8 to finish doing its thing, let's talk about why the app has crashed. R8's primary goal is to optimize the app for size and speed. The R8 optimizer works best when an app has hard references to the code that you want to access. So if your app or library that you're using relies on reflection, where code inspects and manipulates code that at runtime, R8 might identify this code as unused and remove or rename that target. So this is the main root cause of crashes when enabling R8. To avoid optimizer-related crashes, replace reflection with hard reference where it's possible. Otherwise, you can add classes and methods to keep rules, which tells R8 that this code is used and should not be removed or renamed. That's what we just did. And library developers should bundle consumer keep rules within their libraries that they get distributed, and apps can then automatically use those when they depend on that library. Now, the build should be finished by now. Did not do that right. Here we go. Everything's fine. App now runs, is optimized. Thank you very much. Instead of waiting for the benchmarks and everything to finish, let's just switch back to the slides to see the improvements. Again, we're looking at the improvements here. After optimizing, numbers are better, like 21% better startup time, 50% better JIT count. JIT time is a bit up. Well, we'll see about that. Class initialization is down by 36% as well. We have 6 milliseconds shaved off on the 95th percentile, 13% more frames rendered during the same benchmarks, and the app size has been reduced by 73% in that case. By just applying these optimizations with R8 in full mode, you have a significant impact on app startup and runtime performance. Well, I just want to get rid of that just-in-time compilation time and that frame overrun. I would really love to see what we can do there. We can easily by well, enabling baseline profiles and startup profiles as part of the profile-guided optimization. Sometimes that's not enough. Here, it's great, though. Just-in-time compilation now completely removed. That's awesome. The class initialization is down to 90%. It's down by 90%. 55% more frames were able to be rendered in the same time. And the startup time has improved from 21% improvement to 36% faster app startup. So that's significant performance gains, right? With R8 on the one side and profile-guided optimization on the other side. Well, you could say Androidify is relatively small, and you wonder how that holds up in a real-world app. So we're going back to Reddit, where the Reddit team was super helpful, and they provided us with 2 different versions of their app. One is not optimized, and the other one uses R8. So let's take a look. We did the same thing here. We basically started the app, scrolled down, and then scrolled up again a couple of times. I ran those tests on with both the unoptimized and the optimized one on a Pixel Fold. So let's see what happened there. After applying the optimizations, the startup time in total dropped by 55%, and the app was fully usable in 18% less time waiting for the users, which, again, is quite significant for a very quick fix. With a baseline profile that did not cover everything just yet, so parts of the use case were covered, the just-in-time compilation dropped by 2/3, and the just-in-time compilation time already dropped by 1/3 at that point. And frame rendering is already way below the threshold, dropped by 12.8 milliseconds. So you see that it was above that before. And the total frames that were rendered was more than 90% more frames were able to be rendered after applying these optimizations. And the app size was reduced by over 1/3 after applying R8. So this shows, again, how large apps can get a significant performance boost from applying readily available tools like R8, baseline profiles, and startup profiles. So really no wonder that users really liked it a lot more after the optimizations. So start using Jetpack Macrobenchmark and use the new UiAutomator API, Startup Insights, and App Performance Score. To make performance leap, use R8, use startup profiles, and baseline profiles. And that's all from me. Let me pass it back to Alice to talk about powering up your app performance and stability using Android Vitals.
Thanks, Ben. Hello again. So we've been making some awesome changes in App Vitals within the Play console and tooling to power up your performance and stability. App Vitals in the Play console helps developers monitor and improve performance and stability of their apps. And you can get to the vitals from your recently designed overview page in the Play console. Historically, the most important metrics in App Vitals, the core app metrics, have been around stability, user-perceived crash rate, and user-perceived ANR rate. This year, we're making some changes to the core App Vital definitions to also include metrics that contribute towards high battery drain. On Wear OS, we have introduced an excessive battery metric. Your app is considered excessive if over 1% of Wear Watch Face sessions have a drain rate of over 4.4% per hour. This causes the drain rate to not cause the app to last the whole day. If you're interested in learning more about avoiding excessive battery usage on Wear OS, spoiler alert, it's by adopting the watch face format. Check out our blog post on what's new with watch faces. What we'll focus on this talk is the mobile device metric. We have introduced excessive partial wake clock metric, currently in beta. In this current metric definition, the Android Vitals reports that partial wake clock usage is excessive when all of the wake clocks accumulated while running in the background run for 3 or more hours in a 24-hour period for more than 5% of total app sessions. I should caveat that this metric is still in beta, so the definition will evolve over time. If you exceed the threshold for either of these scenarios, you may eventually see your app visibility impacted in the Play Store. So better pay attention carefully. Now, you may be wondering, what is a wake clock? A wake clock is a mechanism that keeps the app awake with the CPU running, even if the user isn't actively interacting with it. You may have also noticed that we are focused on the metric partial wake clocks. But what does partial mean? If you hold a partial wake lock, it will ensure that the CPU keeps running despite the screen being off. A full wake lock, however, prevents the screen from being turned off as well. Wake locks are used to prevent the device from entering a low power state, ensuring that certain tasks can continue to run in the background. In this diagram, the orange indicates CPU activity, preventing the device from entering power-saving modes such as doze. A valid reason for requiring a wake lock may be to complete a user-initiated action, such as downloading a large file. Once the wake lock is released, the green indicates when the CPU is idle, reducing the amount of CPU activity. However, when wake locks are used excessively or improperly, they can lead to significant battery drain. For example, we've seen scenarios where apps have chosen to hold a wake lock for hours at a time or did not properly release the wake lock, leading to frustrated user reviews calling out battery drain without their interaction. There are 2 methods that partial wake locks can be acquired. An app manually acquires and releases the wake lock using the Power Manager APIs for a specific use case. This is often used in conjunction with a foreground service, a platform API intended for user-visible operations. The second scenario is when the app wake clock is acquired by another API, attributed to the usage of that API. You might be surprised to hear that even if your app doesn't contain any code that acquires and releases wake clocks, the app can still be deemed to have excessive wake clocks due to usage of these APIs. So what better time than now than an interactive session? It is time for wake clock trivia. Woohoo! So I'm going to ask you to shout your answers as fast as possible, and we're going to do a speed round. So the question is, which of these use cases do you think would manually acquire a wake clock or use APIs that would hold a wake clock on your behalf? You can either shout manually or use APIs. Let's go. Schedule a periodic sync in the background to download fresh content for offline viewing. What do you think? Shout it out. Use APIs. OK. The answer is that no manual wake clock is needed. So you are right. The Work Manager or Job Scheduler are task scheduling APIs that are intended for this use case. And when these APIs are used, a manual wake clock is not needed. If you're not familiar with these APIs, Work Manager is a Jetpack library that relies on Job Scheduler system API to schedule jobs that keep the app alive while the task is scheduling. This is why you would see wake clocks with the name job associated with the workers. Our second scenario is playing audio in the background. All right, I'm hearing some APIs. The answer is also that manual wake clocks are not needed. When an audio track is playing, the system actually automatically acquires a wake clock when this happens. I also want to note that system-held audio wake clocks are exempt from the excessive wake clock calculation in App Vitals. We have another scenario around communicating via Bluetooth. What do you think? I'm hearing some manual ones. All right. So manual wake clocks may be needed in this scenario. There does not exist an API that holds the wake clock during communication, so you may need to use Work Manager to schedule that task, or hold a manual wake clock if communication should happen while the screen is off. And our final scenario is using location. What do you think? APIs. All right, you guys are good at this. So manual wake clocks are not needed when you're receiving location events in Location Manager. A wake clock is held briefly for that period of time when that location event occurs. So thankfully, you do not need to memorize this extremely nuanced information. You can reference this newly created documentation to understand further. So now that we've learned about how the new App Vitals, what the new App Vitals are and what wake clocks are, let's learn about how to debug excessive wake clock usage using the new Vital dashboards. Let's suppose you log onto your App Vitals dashboard and you see the following alert. Oh no, Play has found that your app indeed has excessive wake clocks. So what now? How do I debug the excessive usage? We're going to run through two scenarios based off of real-life examples where we've seen developers encounter this excessive wake clock usage. Number one will be a simple scenario, and number two will be a more complex scenario. So in this first scenario, I built a weather app that periodically updates the weather using to display in a widget or notification format. Unfortunately, something is causing the excessive wake clock usage. When I go to my App Vitals dashboard, I see something like this. I'm able to see that 11.59% of overall sessions are deemed excessive, which greatly exceeds the 5% threshold. This doesn't give me a bunch of information to start debugging, so I'm going to switch over to this other dashboard, the stuck partial wake clocks. If you're wondering why there are two metrics with wake clock information, it's because the new metric is still in beta, and we're working on combining these information into a singular dashboard. Within the stuck partial wake clocks dashboard, I'm able to see a list of wake clock names. In this scenario, I have a wake clock name called job package name system service under the Android X work package. If you've been paying attention, you may have remembered that Work Manager uses Job Scheduler, which holds wake clocks. So I've narrowed down some use cases that are using Work Manager that I think might be contributing to the problem. And I'm going to switch over to the demo so I can show you. So I have opened up a debug instance of the app, and I've already played around with it. And I need to make sure that my app is running API 26 or higher. I'm going to go into View, Tool Windows, and App Inspection. And what I want to click on is this background task inspector here. So I'm already seeing a lot of things that don't look great. First of all, I'm seeing a lot of workers failing, and that's not great. And secondly, I see a lot of retries. There's a high number of retries on every single one of these workers. When I click into it further, I can see that some of these workers that are failing are called weather sync worker, giving me a better understanding of where I can start debugging and which worker is failing constantly. It also gives me some information about the run count, and if it was still running, it would tell me what the running situation is. And if we can see here, we can also see the worker chain graph, so that this was actually started from the start foreground service worker. So with all of this information, I can now figure out exactly what worker is not doing so great and further debug from there. So let's switch over to the slides. Now, this tool seems great for debugging work manager-related reasons that are causing excessive wake locks, but what happens if I'm having multiple APIs acquiring wake locks, or I have manual acquisitions of wake locks? In the second scenario, we're going to debug an app that is much more complex. This scenario has location tracking using Location Manager, a usage of device sensors, as well as work requests that are running in the background. Here is another stuck partial wake lock dashboard with a long list of wake lock names. Some of the worst wake lock sessions in this scenario have the names System Foreground Lock, Location, and Health App Sensor Wake Lock. In order to debug these particular wake locks, I'm going to use a tool called Perfetto. Perfetto is a platform instrumentation tool for instrumentation and analysis. It helps developers better understand how their software behaves in terms of resource usage and identify bottlenecks. I've already collected some system traces that I've manually collected while using this app over a long period of time. And there are a number of methods to collect this systems trace through Android Studio, the web interface, or directly via developer options. You can even collect the traces in production with a newly created platform API called Profiling Manager, introduced in SDK 35. So let's go check out our demo. So this is what our Perfetto trace looks like, and it is pretty confusing. But fortunately, we're not going to need all of this information. What we're going to do is scroll down to device state and pin a few of our key things. So I'm going to do top app. I'm going to do the foreground app, long wake locks, and jobs. And using this, I can better understand what the top app was while the trace was running, and look at the number of long wake locks that occurred. So in here, we can see that there is a foreground processor lock that is happening in occurrence with the job wake lock as well. And this is what's happening when I create a foreground service through Work Manager. I also have a health app sensor wake lock. When this health app sensor wake lock happens, it's happening for a very long time. And there might be opportunity for me to optimize this sensor wake lock by reducing the wake lock duration or reducing the sensor usage. And finally, we have this location burst collection trigger that happens when the wake lock occurs because of location events. If we're looking specifically for the location wake lock, however, that is a different section because that is not a long duration wake lock. So I'm going to have to zoom all the way in to see these very small duration but frequent location wake locks. Right. And we're going to go back now to the presentation. So that was how to debug wake locks. I want to leave with one final thing. What about debugging app stability issues such as ANRs? In the past few releases, we've been supercharging your ability to debug hard-to-reproduce issues to further optimize your application. We recently added the application start info in SDK 35, which is valuable for debugging performance bottlenecks at app startup and provides a detailed information on reasons why your app started. And also, we are improving application exit info, which gives us valuable process death information for debugging crashes and ANRs. And because ANRs are so notoriously hard to debug, let's dive into it. Here is a really confusing ANR that we've seen a lot of developers struggle with: no response to on-stop job. And I'm feeling this at this moment. I can't understand this tag trace, and it's not helpful. And I can't reproduce it locally on the device. So how do I use application exit info to debug this exception? I'm going to switch over to my code. And we can see my application exit info logger here. So what I do is I use Activity Manager to get the historical process reasons. This gives me a list of all the recent reasons why the app crashed or exited, and I can filter the reason by reason ANR. I can also get the description, the process importance, which better helps me understand what state the app was in when it was exiting, such as a foreground service state, a cache state, or a visible state. And finally, we can get the tombstone stream. The tombstone stream is very helpful for understanding ANRs because it gives us a trace of every single thread at the time of process exit. So switching over to the slides, here is a truncated version of what this tombstone trace could look like at the time of process death. It looks like in this scenario, we have a media API connect on handler that is taking a long time to execute and is blocking the main thread, and thus the stop job callback is unable to execute. This is what potentially resulted in the ANR. This is great information that I wouldn't have otherwise gotten while debugging these elusive ANRs. So even if you don't use app exit info to log this data, you can see a simplified version of this info when you drill down on a user perceptible ANR in your app crashes and ANR's dashboard in Vitals. Locate the ANR that you're debugging and click the blue arrow to view further details. Our documentation on diagnose and fix ANRs offers valuable insight into the reasons why ANRs happen and how to reduce them. So that's all from me for powering up your app visibility with App Vitals, where we learn about battery drain and the tools to debug their usage. We also learn about improving app stability using new and improved platform APIs. And I'll invite Ben to wrap us up.
All right. Thank you so much. Awesome. We've shown you a range of tools and techniques today, all aimed at making it easier for you to improve your app's technical performance metrics and business metrics, and in turn improve customer or user satisfaction. To analyze your app's performance, write and run performance tests using Jetpack Macrobenchmark with the new UiAutomator API, see how well your app performs with the recommendations of the app performance score. And you can see big improvements in performance by applying the R8 optimizer and start using profile-guided optimization.
We also learn about updates to App Vitals to expose battery drain, identifying issues with wake locks, and some of those APIs you can use to investigate frustrating ANRs. We hope that you feel empowered to tackle on app performance challenges, and everything we talked about can be found in those links or by continuing a conversation with us.
Now it's your turn. Go ahead and apply these low-effort and high-impact performance optimizations in your apps.
Thank you.